Hello, welcome to this video. Today I show you how to analyze dynamic SPECT/CT datasets with the Emalytics preclinical software. I will open the software first, and you can find an example dataset under Tutorials, PET/SPECT, SPECT/CT Dynamic, Load Example dataset. I will open the Corona slice view and the 3D rendering. Let me rotate it a little bit, like this. And you see a CT scan of a mouse as underlay and some SPECT data as overlay. When I select the overlay here. And this dataset was acquired with a Mediso system. When I go to the time module of the Emalytics preclinical software, you can find it here on the left side, symbolized by the screen stopwatch. You can see that there are 6 time points. And I can go through the time points. And you can see that there's an accumulation, or that the tracer accumulates in the tumor here, in the stomach, as well as in the thyroid. Let me rotate it a little bit. And go back in the time, and yeah, now you can see the accumulation in the thyroid. Okay, and to visualize it a little bit better, I will clean up the CT dataset first. So for example, we have here a breathing pad for respiratory gating, and to get rid of it we can use the ISO tool. So I go back to the underlay, I rotate it again, and now I will use the ISO tool. It's here on the left side, and just click on the pad. I will add a class named pad. Okay, when I now hide the underlay, again I will press here and here. On the tube. Now I can see that parts of the pad were segmented, and I will dilate it with 3 voxels. So right click on the pad, Morphologic, dilate with 3 to make it a little bit thicker. And to get rid of it, I will go to Edit, adjust intensity of input class, set to constant, and set this intensity to -1000, which corresponds to air in a Hounsfield calibrated CT scan. Now I will delete this class. And let me show you the underlay again. And now the pad is gone. And you can try to do it in a similar way for the mouse pad, but I recommend to use the image cleaning mode. It's here. But first let me rotate the mouse a little bit. Like this. And you can use the image cleaning in 2D and in 3D. And if you have questions about the image cleaning, there's a special video about it. It's here. You can find it here under play video. And we can get rid of it. We have to set the intensity to -1000 again. And now we can delete the parts here and here. And in this way we can clean up the data set, just to make sure that you don't delete parts of the mouse. But if you made a mistake, if you deleted some parts, you always can undo your last image operations with the undo button here. I will rotate it. Can also get rid of this part on the top. Can also adjust the windowing a little bit, but I think it looks nice. And now we don't have the bed and the respirator pad in the way, so we can see the signals in the thyroid, in the stomach, and in the tumor a little bit better. I will adjust the windowing of the overlay, therefore I select overlay as selected layer. Then I go to this windowing button, and I will change it, the maximum value, to approximately 3000. So now you see the signal, it's very nice. And this is the last time point. You can see it here. You also see when the time points were acquired, so 240 seconds, 480, and so on. Now I would like to segment the organs. So I will start with the stomach. So I will add a class stomach. And I will use the ISO tool again, but this time I will use the ISO tool on the overlay. So I just click inside the stomach, but this doesn't work in 3D. It only works not in the volume rendering. When you change it to ISO rendering, then it works. But to segment it in this case, I have to go to a 2D slice view. So I just click here and here. And now the stomach is segmented. And we couldn't do it in the same way for the thyroid. So I will add a class thyroid. And to perform the segmentation in a more robust way, I recommend to tick here to use percent of maximum. And what it does, it uses it walks to the local maximum, and then it uses 50% of the maximum intensity. And so it doesn't really matter where you click inside the organ. So in this way it's a little bit more accurate, more reliable and more robust. But it's also explained in the video about the ISO tool, and you can watch the video here under play video if you have more questions about the ISO tool and about this function percent of maximum. And finally I will segment a tumor. So I will add a class tumor. And then I go to the tumor here, and in this way I have the 3 organs segmented: the tumor, the stomach, and the thyroid. And now we can check out the statistics. So we go to statistics, class statistics selected layer, we have the overlay selected. So we will get the spec signals for the organs, and we will get 6 values per organ because we have 6 time points. You can see here the volume, and the volume is constant, of course, for each organ. And then we have here the mean in kilobecquerel per ml, and you see an accumulation in the organs. And when you go to graph, you can also see the graphs. And you can save it to Excel, and then you can further process or analyze these data. And yeah, this is the uptake over time. Okay. I hope this helps. Thanks for watching. Bye bye.